A straight line can be represented by an equation y is equals to mx plus b. And this is the equation of any straight line. In this video, what we're going to do is we're going to build up the formula y is equals to mx plus b. If we present numbers in a straight line, we do have the positive side on the right and negative side on the left. And this is our origin. Suppose I say count number 4, you go 4 steps on the right, and negative 5, you go 5 steps on the left. However, if we have to pull in a point outside our number line, just like this, then the only way to plot this position of the point is by introducing the xy coordinate with positive values on the top and negative values on the bottom. So in this case, we have a point A which can be traced from x-axis at position 4 and 7 at y-axis, connecting them, and then we have our point as 4, 7, which 4 represents the value of x and 7 represent the value of y. Now with this, we can plot any point on this xy and we can define it by the xy coordinate. Let's start building up our formula of y is equals to mx plus b. So we bring up the xy axis. I'll only use positive values for now, just for the purpose of demonstration, and we mark these points on this graph to represent y is equals to x. When x is 2, y is 2. When x is 4, y is 4. When x is 6, y is 6. Subsequently, we draw a line to show our equation of the line y is equals to x. Now, let's change the equation slightly and mark it as y is equals to 2x. We do the same thing again, build up our xy table to compute the numbers, then plot them on the graph. So when x is 1, y is equals to 2, we mark the point. When x is 2, y is equals to 4, we mark the point. And when x is 3, y is equals to 6, and we mark the point. We join the lines and we have green line. Now what you have to notice is that there's not much difference between the line that I just drawn with the previous one, except that the yellow line, if I pull it back, it has a different slope, and there's a shift of the green line on the left. The green line is y is equals to 2x and the yellow line is y is equals to x. This tells us that what is changing is actually the slope of the line, or rather the angle of the line, and this is equally known as gradient, which is now our third variable m. In the first line, y is equals to x, we didn't show m because any number multiplied by 1 doesn't make any difference. The second line, since it has a significant difference when you multiply by 2, then we have to show y is equals to 2x. That tells us that I give you a point there on the graph and the second point on the graph without necessarily showing you the gradient. How do you calculate that? For calculation of gradient, we calculate the change in y divided by the change in x. Now that is the change in y-axis from 6 to 4, and that is the change of x-axis from 3 to 1. So this gives us 6 minus 4 and 3 minus 2, which equals to 2 over 1, and the answer is 2. So that 2 represents our gradient. So far what we've seen is that y is equals to mx, and both two lines, the green and the yellow, actually slices through the origin. So we are going to change the positions of the line. So we'll pick the yellow line. Now instead of the line passing through the origin, I'll pull it up and passes through the point 2. So this has an impact to our equation y is equals to mx, because if we go by the original calculations, we see that when x is equals to 0, so we multiply mx by 0, then we see x is equals to 0, y will be equal to 0. But now for us to specifically show the point y, we have to approach these equations with a difference, and the difference we're gonna apply when x is equals to 0, which is our position in orange circle, y is equals to 2. Hence we add 2 to the equation. Now with that, the value that we've seen 2 is actually the value that is b. Hence, b is the value of y when x is equal to 0. And that is the equation of our new line, y is equals to x plus 2, as opposed to y is just equals to x. What we've come to conclude is that m is the slope and b is the value of y when x is 0. But how do we use this? For example, in this equation here, where we have y is equals to 3x plus 2, here we know that m is equals to 3, which is the gradient, and b is equals to 2, which is a point on the y-axis when x is equal to 0. And then what we have to identify is that change in y is 3 and change in x is equals to 1. Therefore, this is what gives us gradient 3 over 1. So if we go to map it on the xy plane, we move one step to the right, and then we move 3 steps up, and then from that we mark the point, which is our second point of the line. And these 2 points, we use this to draw our straight line, and that is the solution to our problem. So those 4 variables can be worked out, and you can derive them to actually use it. So with this one, we drew the line without necessarily plotting the x and y values. And this is how you approach such equations. In the next videos, we will see how these ones can be used to solve such problems. Thank you for your time, and see you in my next video.